Dear students, today I am discussing this example 1.1. The electric field components in figure, given figure, this figure are Ex alpha x to 1 by 2, Ey Ez is equal to 0, in which value of alpha is given. Calculate A, the flux through the cube, and B, the charge within the cube. Assume that A, that is side of the cube, is 0.1 meter. 0.1 meter. Now you see electric field is only in x direction. This is the direction of electric field. Okay. Now this electric field is parallel to this surface. Also parallel to this surface. Bottom surface. Also parallel to this shaded surface. And also parallel to this front surface. So here are these four surfaces for which electric field is parallel. This top one surface and this one surface shaded, bottom surface and front surface. Only blue surfaces, only on the blue surfaces electric field is perpendicular. Okay. And you see on this surface electric field is outward, and on this surface, this side, electric field is inward to the surface. So for this we take area vector. You know, we take area vector perpendicular to the surface, perpendicular to the surface. This is area vector. This is area vector on this surface. Okay. And this is area vector for this surface. Okay, try to understand the concept. Okay. And electric field, this is electric field, and this is area vector A. This is area vector A. This is electric field. Okay. On this surface, top surface, area vector is always perpendicular to the surface. There is 90-degree angle between the direction of electric field and area vector. For this surface, for top surface also, in this side. So all these four surfaces which are not blue, there is angle theta between E and area vector, which is 90-degree. That is pi by 2. Okay. So these four surfaces will not contribute any flux. Because what is flux? Flux is E A cos theta. And for these four surfaces, theta is 90-degree. So cos 90 becomes 0. So these four surfaces will not contribute in the flux. Only rest surfaces are these two blue surfaces. Okay. For this blue surfaces, we call this right one surface and this is left one surface. Okay. And distance, this is the origin. Distance of left surface from origin is A, and distance of right surface from the origin is 2A. So right surface is at 2A distance. Left surface is at A distance from the origin. Okay. So the formula of electric field is given to us in the question. Electric field changes according to this is in x direction, alpha x raised to 1 by 2. This is the basic formula of the electric field. Electric field is changing according to this formula. Depends on the x. Okay. So this is changing. So now let us calculate flux for left surface. This will be E for left surface multiplied by, now theta is 0 for this surface as well as for this surface. So electric flux formula will be simply E into A. In some books this is also written E into S. S is surface area. So this is the simple formula we are going to use. So electric field for left surface multiplied area of the left surface. This is cube of side A. So area will be A square. Move further. Flux for left surface is equal to, now what will be the electric field for left surface according to this formula? This will be alpha into distance of the left surface, which is A raised to 1 by 2 and multiplied by A square. So flux for left surface is equal to alpha, you can write A raised to 5 by 2. This is, you can call this is equation number 1. So we have calculated flux for left surface. Now here one more point. Now see, here theta is not 0, this is actually 180 degree here in this case. For this left surface, theta is 180 degree. See here, electric field is opposite to area vector. So theta is 180 degree. Theta is 180 degree. So angle between electric field and flux here in this case is 180 degree. So this will be, flux for left surface will be minus alpha A raised to 5 by 2. Minus. So keep in mind this will be minus. So now let us go for calculating electric flux for right surface. For right surface. This will be electric field for right surface and multiplied by area will be A square. Next step, flux for right surface is equal to, what will be ER? Use this formula to find the ER. This will be alpha into, now this x is now 2A, A plus this A, 2A raised to 1 by 2 multiplied by A square. This will be positive, okay? This will be positive. So flux for right hand face, right face is equal to alpha, solve it, under root 2 A raised to 1 by 2 multiplied by A square. This will change to flux for right face is equal to under root 2 alpha again A raised to 5 by 2. Okay. So now total flux, we have to calculate total flux, F net. This will be sum of right plus left surface flux. We put the value. Now see, alpha into a raised to 5 by 2, alpha into a raised to 5 by 2 will be common. Okay, alpha a raised to 5 by 2 is common. Inside the bracket, what is remaining? Under root 2, this is minus, okay, under root 2 minus 1. Net flux is equal to, now let us put the value of alpha. Value of alpha is 800. Value of A is 0.1 meter. Now A raised to 5 by 2 means A square into under root A. Okay. Under root 2, 1.414 minus 1. Net flux 800. Square of the 0.1 will be 0.01. That is 1 into 10 raised to power minus 2. Under root A means under root 0.1, that is 1 by 2, 1 by 10. So under root 1 by 10 multiplied by 0.414. So net flux is equal to 800 into 10 raised to power minus 2 into 0.414 divided by under root 10. So you have to put the value of under root 10. This is 3.16. 3.16. Solve this. This 20 will be cancelled. 8 into 0.414 divided by 3.14. This will approximately comes out to be 1.05. And unit of the flux will be Newton meter square per coulomb. So this is the final answer, total flux. This is the answer of the A part, answer A. Now charge, total charge. According to Gauss's theorem, charge, net charge is equal to net flux multiplied by epsilon naught. So net charge is equal to net flux is 1.05 multiplied by 8.85 into 10 raised to power minus 12. Solve this, you will get the charge in the coulomb. 1.01 into 8.85, 1.05 into 8.85, 9.29. 9.29 into 10 raised to power minus 12 coulomb. This is the charge. So this is the solution of this NCERT numerical. I hope you will find it interesting, and this is very clear.